Question number 23, and that says prove that the volume of the largest cone that can be inscribed in a sphere of radius capital R is 8 by 27 times the volume of the sphere, which means I have to prove it is equal to 8 by 27 times, and the volume of the sphere is 4 by 3 pi r cube. So it is given to me over here that the radius of the sphere is capital R, and maybe I take the radius of the base of the cone as small r, and the smaller part I am taking as x, and let this cone be represented by ABC and volume of the largest cone. So I have to start with volume of the cone, which is equal to 1 by 3 pi r square h. R is the base of the cone. And then you can see here my answer is expected in capital R. So I'm going to convert everything in terms of capital R, 1 by 3 pi, and you can see this is a right angle triangle. So I can write it as r square minus x square, and that height of the cone is r plus x. So therefore this is my expression number 1. If I have the value of x over here, I can write down my answer. Just for my conveniency, I am breaking it up, the first part as a minus b into a plus b, so that the power shifts here on top, and then I use the product rule. So dv by dx is equal to 1 by 3 pi, and that's a constant. First function, derivative of second, plus second function and derivative of first, which is a minus 1. The advantage with a power on the top is that you can take out certain terms common. So here r plus x and r plus x can be taken out common. I need not expand it. So this will give you 1 by 3 pi, and r plus x is common, leaving me with 2r minus 2x minus r minus x. So this one is x, and therefore dv by dx is equal to 1 by 3 pi r plus x and r minus 3x. This is my second expression, which is the simplest one, so I shall be using it for double order derivative. But when you put a dv by dx is equal to 0, you are going to get a r plus x is equal to 0. That implies x is equal to r. Now this is not possible. If I put x is equal to minus r, this is a minus r, minus r. If I put x is equal to minus r over here, the cone will have no height. And the other option is r minus 3x is equal to 0 gives you x is equal to r by 3. Substitute in 1 and you get volume of the cone is equal to 1 by 3 pi and r square minus r square by 9 into r plus r by 3, and therefore this is going to give you 1 by 3 pi, and when you take the LCM, 8r square by 9 into 4r by 3, which is going to give you volume of the cone is equal to, and the required answer, 8 by 27 times and 4 by 3 pi r cube. So that is what was required over here. Then finding out a double order derivative from 2, we have d square v by dx square at x is equal to r by 3 is equal to 1 by 3 pi, and you get first function, derivative of second, which is minus 3, plus second function and derivative of first, which is 1. So if I put here x as r by 3 and here x as r by 3, this part will become 0 and I get a 1 by 3 pi into 4r by 3 into minus 3. So I can cancel out this 3 and 3, giving me the double order derivative as minus 4 pi r by 3, which is less than 0. Hence, the volume of the cone is maximum. And then the 24th one, show that the right circular cone of least curved surface area and given volume. So the least curved surface area of a cone, so I'll start with the curved surface area, which is pi rl, and it says the volume, given volume. So I've written volume is equal to 1 by 3 pi r square h, and we have to show that the altitude is root 2r. And you can see over here that I require a h and a r. So the first thing that we do over here is write s is equal to pi r, and l can be written as under root of h square plus r square. And then I'm squaring both the sides just to remove that under root, and I'm representing a symbol z, giving me pi square r square h square plus r square. And I take the value of h from here as 3v by pi r square. Substitute the same. I will get z is equal to pi square r square, and that value of h, which I have taken from the above expression, is 3v square by pi square, that's a 9v square, you're squaring it, 9v square pi square r to the power 4 and plus r square, like this. So I am multiplying the first two terms, and you can see here when I multiply I get 9v square, a pi square and pi square gets cancelled, in the denominator is r square, plus pi square r to the power 4. This is z. So we get a dz by dr is equal to 9v square is a constant, and the derivative of r to the power minus 2 is minus 2r to the power minus 3. So I'm writing here minus 2 and r cube plus pi square, and this will give you 4r cube. Now if you put a dz by dr is equal to 0, we are getting a minus, so this will become plus 18v square by r cube is equal to 4 pi square r cube. I can though reduce this to a 2 9s are 2 2s are, and I get a 9v square is equal to 2 pi square r to the power 6. Put back the value of v, which was 1 by 3 pi r square h. So 1 by 9 pi square r to the power 4 h square, and here is 2 pi square r to the power 6. 9 and 9 goes, pi square and pi square goes, and I get h square is equal to 2r square. So that implies h is equal to root 2r, which was my expected answer. Next, what I need to do is find out the double order derivative of this. So d square z by dr square is equal to, and this is minus 18 v square, and same ways the derivative of r to the power minus 3 is minus 3 r to the power minus 4. So I'm writing here minus 3 and r to the power 4 and plus pi square and into 12r square. So you can see this negative and negative will become positive. We know that the volume is greater than 0 and the radius is also greater than 0. So d square z by dr square is greater than 0. Hence, the curved surface area of the cone is least.